So these two changes can also change our curve, which will change these three areas. So remember, those are the things that we do. We don't stick with one model if we get more income. Am I putting more or less if I got more income? Or if I find out I haven't been buying DVDs in a month because I'm streaming, maybe I want to take that money and put it someplace else. Different choice of where I'm going to use my money. So that's what this is talking about. All right, now this is what the worksheet should look like. Make sure you understand it, because as we go, remember in our conference class, we're going to be talking about the real world stuff of these things, how it affects in the real world. Stuff with executive orders, stuff with pipelines, energy. We're going to be talking about this kind of stuff based on the things that we're working here. And remember, you're going to have to send all those to me. All right, now I want you to get the production possibilities model worksheet. All right, it looks kind of like this right here. And this is one I finally took the thing out so you can see what it looks like. What we're going to do is we're going to work on this part first, then we're going to work on this part, then we're going to work on this part. All right, so it's going to be this part first that we're going to be filling in. Now, the thing that we have is you can't hit a moving target. If you're planning a trip and you're going to drive, and all of a sudden the states keep changing who's closed, what's closed, do you have to quarantine, how long do you have to quarantine, etc., and you're trying to figure out how to drive across country, you may not be able to do it. So we have to make some assumptions so that we can go ahead and actually make a good plan. And that's where we start with. We can't hit a moving target, so we have to make an assumption. So first off, on that left-hand side, our first assumption is we're going to be at full employment. Now, what that means is all available resources, we're using all of them. Right? Full employment of all available resources. In other words, our land, labor, capital, and entrepreneurial ability, we're using them all. If it's in a business, if I have 10 people working for me, 5 machines, and a factory the size of 2 classrooms, I'm using the entire floor of the 2 classrooms. I have all 5 machines operating, and I have all 10 people working those machines. I don't have 10 people today, 8 tomorrow, 6 next week, 23 the week after that. No, I have 10, 10, 10, and 10. Okay? We're using all of the resources, and here's where they don't change. They're fixed. Quantity, and I just went over that. But also quality of the resources. Let's take our people again. I don't train them. Right? I assume that their training is at this level, and that's where I'm going to build this model. And of course, technology. How we do things. All right? I'm not going to add technology. I'm not going to increase or change processes and procedures and stuff like that. So, quantity doesn't change, quality doesn't change, technology doesn't change. Now in the chapter, it also talks about free trade. We're going to get into that in the international trade section, so just kind of hold off on that free trade thing for a minute. The third example is full production, or excuse me, our third assumption. Now in full production, we're talking about 2 things. Productive efficiency is the first one, or in other words, the least cost method to produce something. And that doesn't mean it's cheap. We have a certain quality that we're going to produce to, but the production process is the lowest we can make it for that quality. And we have allocative efficiency. That means the right mix. In other words, what I buy, what I make, my customers are buying. Let's take a company that builds 1,000 vehicles. We build 950 electric cars and 50 trucks. Now, my guess is those 50 trucks would probably be sold out in the first week. And at the end of the month, I might have 800 or 900 electric cars still sitting in the lot. That's the wrong mix. Maybe it should have been 50 electric cars and 950 trucks. I want to make sure that what I make is sold and I don't have any left over. So productive efficiency, least cost, allocative efficiency, the right mix. Now I know the book talks about pizzas and robots. We're going to go ahead and talk about consumer goods, the stuff we eat now or consume now, and capital goods, the stuff we do in the future. Now how would this equate? Here's our pizzas. We're not going to save a pizza for 5 years before we eat it. We're eating it now. Think of the robots as pizza-making robots. That's capital that we're building to build more pizzas in the future. Now, why would we need that? Well, let's say, here's today. Right? We have 30 people in our class, and tomorrow, Armageddon, the entire world except for our class is gone. We figured out how to feed all of us 3 meals a day with snacks with what we've got. The problem is 20 years from now, our 30 might be a little bit bigger. And if we're only consuming all of the stuff and we're not doing any capital goods, in the future, we're still going to have one loaf, but this amount of people. So starvation is going to take effect. So we have to do both. Because we're not going to do just capital goods here and no bread because we'd starve here. So we got to find that right mix of production. Okay, so here's how we do it. Remember, here's our production process. This is what we're looking at. Here is the conversion part. These are the different production options. In other words, our conversion and the inputs we use to the conversion are production options. That's what that table is showing us. And instead of pizzas and robots, we got capital goods and consumer goods. Now, here's what happens. We have efficiency experts, because remember, we're looking at efficiently doing something. They bring all their stuff in, and basically that means one little laptop computer. Why? Because their algorithm is right in that computer. Their algorithm telling us what different production options we should do with the decisions of how much we need to make of one or the other. In other words, the right mix. So the first thing they do is they go ahead and they say, well, give me all of the materials that you're ordering so I can put them in my little computer here. You know, we're trying to find out whether we're getting good quality, medium quality, poor quality, trained workers, kind of trained workers, no trained workers, all that kind of stuff that goes in there. So we do that with all of our resources. And then what they do is they just arbitrarily pick, they say, well, if we make no capital goods today, so they put 0 capital goods and they hit enter. So if we use all of our resources just to make consumer goods, we can make 10,000 loaves of bread or 10,000 pizzas. But we're making no capital goods, no robots. Then the other side is, well, what if we made no consumer goods? So we put the 0 in for consumer goods, we hit enter, and we find out that we can make 400 capital goods or 400 robots with the resources that we have. And then we just pick one or the other and we go down the line. If I want to make 100 capital goods, I can make 9,000 loaves of bread, 200, 7,000, 300, 4,000, and I now have all of the different options that I can go ahead and put on my graph. So right now, graph these 2 columns right here. And notice there's a big open spot. That's where the graph should go. So I'll give you a minute to go ahead and fill that out. All right, so if you did it right, you should have gone ahead and there's A, B, C, D, and E. A, B, C, D, and E right here. We connect the dots, it looks like that, and that's our production possibilities curve for this table, for the research that we did putting it all together. Okay? Now, here's the thing. All points on this curve, remember in the previous one, we said we can make all those combinations. So, they're all attainable. They're productively efficient. We're using all the resources. And it's the least cost production method if we are on that curve. So that's what we're building in, that's what we're building into. All right, we took that other one and we brought it here. On the previous one, all we said is, hey, they're all attainable. Well, now we're adding two more things to it. Productively efficient and least cost production method. Now, 1 point and 1 point only on this curve, we also have the right mix. Meaning that we have the right number of consumer goods and capital goods to feed our population. Or enough pizzas and pizza-making robots to go ahead and feed everybody for the Super Bowl Sunday. So we are productively efficient, but we also have to be allocatively efficient. So on this curve, there'll be one combination. At this point, I'd ask, does that change? And you should be shaking your head up and down yes. Okay? Why does it change? Who are we dealing with? The answer should be people. We may like pizza today. We may even like pizza tomorrow. But that third day, we're kind of getting tired of pizza. As a matter of fact, we might not have pizza for a whole nother month if we have too much of it in a row. So it does change. And we just have to be flexible to go ahead and meet that. That's why we have everybody continuing to look at how we go ahead and keep at least cost and at the right mix. So we talk more about that in the next chapter. Now, plot this dot on your model here. 4,000 consumer goods, 100 capital goods. And what you should have done, if nothing else, at 4,000, draw the line across. At 100, draw the line up. And that's where your dot's going to be. So, what does that dot mean? Going back to the previous model, first off, we see we are under our production possibility curve. We're under that least cost, our attainable curve. Meaning that we have inefficient or underemployment of resources. We're not using everything here. Because remember, in our last one, this is what we said. These combinations were attainable. Anything underneath was inefficient, not using them all. Everything above was unattainable. So here we're inefficient. We need to figure out how to get this up to here. So that's what you're kind of looking at. So inefficient, underemployment of resources, not using them all. Why could this be a problem? Well, let's say the reason you're producing this amount of these two things is because half your workforce is playing cards. Not good. 3 of your machines are broke. That's why half your workforce is playing cards. Not good. So we need to go ahead and fix this problem to get us back up here. Because if we don't, what's going to happen? Company's going to lose profit. Company's going to go under. And if company goes under, no product, no job, and no investments. Can't do this. All right? It's like burning money. Yeah, like that 10 really stupid things to buy, not using production, but bought it anyway. Right? In other words, we bought resources but didn't use them. We just threw our money away. Now, plot that dot. And again, take 8,000, draw it out. Take 300, draw it up. And it should be right about there. Now, of course, this one we notice is above the curve. And when we take a look at our last graph above the curve, it's unattainable because we don't have enough resources. So, unattainable, not using enough resources. Or excuse me, not enough resources. And again, bad thing, but it happens. When I was working in the manufacturing plant, at least once a week, you'd hear, all managers report to the production manager's office ASAP. So we'd all get up there and we'd find out that the salesman, and yes, they were all men, so I'm not being, not compatible here, but they had all sold too much stuff that we could actually produce. So they promised that we'd produce more than we could. Okay? Now, of course, why does this happen? Well, salesmen are paid mostly on, and the word commission should come out. So they don't care if we can produce it. They make the sale, they sign the contract, they get paid. And then the production facility has to figure out how to do it. Well, we'll get to that in a second because that's not good because we can't do it right now because we don't have enough resources. Right? And if we can't meet what was promised, we got customers going to our competitor, which is bad because we'll never get them back. And if we don't get them back, this doesn't happen, and we have enough problems. All right? So, here is what we're looking for. All right? We know that this is least cost. We know that 1 point we're also going to have right mix. We know that above, where it's unattainable, not enough resources. Under, we're inefficient, we're not using all our resources. Those are the key things to go ahead and work with this. And this one right here, make sure you do not lose that, because we are going to need it for later. Now, how do we get to that 8,300? How do we grow the model? Well, remember some of those assumptions we said? Well, we got to increase the quantity and or improve the quality and or improve technology, and later on, and or increase free trade. That's how we get from there to there. We have to change the model. And this is what happens at those production meetings. We figure out what can we do. Can we do it temporary? Do we need permanent? Do I need another machine? Do I need to goose up the machine? Can I go ahead and come up with a different procedure? Right? So there's a lot of different ways to get from here to here. You just have to take a look at them. Some of them cost money. Some of them don't cost money. And the ones that don't cost money are the ones that we normally use. Right? By the way, the ones that don't cost money come from up here. Remember, mental ability of labor. All those managers in the office are trying to come up with a cost-effective way to meet the new goal. Now, as far as free trade, the words specialization and trade come into play. I want you to go ahead and just right now remember something magical happens. We'll get back to that later when we get into international trade. Because the magic part, increased production for both countries, and we'll talk more later. Now, remember we said trade-offs? If I want less of these and more of these, I can do that. Right? I can change my curve. I can change the different production options with the existing resources. But there's a cost. Right? Now, if you notice in our table, you see, we're going to talk about this law of increasing opportunity cost. Because you notice from 0, we got 10. We add 100, we lose 1,000. We add another 100, we lose 2,000. We add another 100, we lose 3,000. Of course, we add another 100, we lose 4,000. Now, how does that happen? Well, remember, first off, we're looking at the resources that we have in our plant. We're not talking about new ones. We're just talking about shifting them. So let's say we're right here, and we go, well, you know what? We're going to start having some babies, so we need to start thinking about this. So when I look at, all right, I'm going to produce 100 pizza making robots or 100 things of capital equipment. What do I look at first with my whole labor force? and the answer should be coming in, I'm looking at the people that are going to make the capital equipment the best. So I go and say, all right, well, this part of the class over here, you are now the ones making my pizza making robots, or making the capital goods. Now, a few years later, we need to double our capital goods. Well, the problem is, we still have, our best are doing this part, so this is now my second best. So now, instead of just, say, one row of folks, to match what they're doing, I need a row and a half of folks. So now I'm taking more people away that are making our pizzas or making our bread. So that's why it grew to 2,000, or it shrunk 2,000. It's the same growth, but I had to have more people do that. And the same thing for the next one. I go from 2 to 3. Now I'm losing 3,000. Right? So in this case, I did a row and a half. Now I need to do 2.5 rows, because that's my third best group. So that's why as we produce one thing, the opportunity cost gets worse and worse on the other, because I need more resources to continue to do these, which means I have less resources to do those. So that's what we mean by the law of increasing opportunity costs. So this is what the sheet should look like. Here's our assumptions, right? There's the 3 assumptions we put together. Unattainable, inefficient. All of these, we are productively efficient, it's all attainable, it's least cost, and one point, and we're just, the example is going to be point D, on the curve is allocatively efficient, or that currently right now today is 4,000 consumer goods and 300 machines. To be changed within a week, within a day, within an hour, depending on what people are looking at doing. All right, now this should go ahead and this ends us at this point. If you have any questions, part of that is on the 3-section assignment. The other part is you can bring it up in class, because we're going to talk about these. Each of these models we're going to discuss, and we're also going to go ahead and see about taking a real world thing into play to make this work. So that's all for this section. Let me see, I think it's all for this section. Yep, that's it. The rest of the stuff we'll talk about later.